Example 4 says find the equation of the normal to this curve where x is bigger than 0 at the point where the curve crosses the x-axis, and give your answer in its general form. So you notice that this curve is only defined for x values bigger than 0. So we're only interested in this curve for x values larger than 0. We want to get the equation of the normal to the curve. The point here isn't actually given. It says the point is where the curve crosses the x-axis. So we're going to actually have to work out the x and the y coordinate of the point this time. So the starting point is the same. Write down your curve. So we've got our curve. We are going to have to differentiate this at some stage to get the general gradient of the tangent, and then get the actual gradient of the tangent, and then use that to get the actual gradient of the normal. So we're going to prepare it for differentiation. So there's a root there that we need to get rid of. So I'm just going to rewrite it as 4x to the power of a half, and then minus x squared over 2, or a half x squared. So it's prepared for differentiation, but we need to get the point on the curve that the tangent and normal both go through. So that's critical. We can't do anything until we know what the point is. So, point. Now, the point is where the curve crosses the x-axis. So it crosses the x-axis when y is 0. So cuts x-axis, we set y equal to 0. So we go back to our curve, we're going to set y equal to 0. So we're going to get 0 equals 4x to the power of a half minus x squared over 2. Okay. And I've just kept x to the power of a half in it and not kept the root in it here. So we have to try and solve this equation. I'm going to multiply through by 2 in order to get rid of the denominators. So we're going to get 0 equals 8x to the power of a half minus x squared. Now, this is quite a difficult type of equation. There is only 2 terms on the non-zero side, so what we're going to try and do is factorize here when there's only 2 terms on the non-zero side. You could do it obviously when there's 3, but we're going to try and factorize here first. So I'm going to lift out the common letter with the lowest power. So I'm going to lift out x to the power of a half. So we're going to get 0 equals x to the power of a half, and then open brackets, we're going to have 8, and then we're going to have our minus. And then you've got to ask yourself, what do you multiply x to the power of a half by to get x to the power of 2? Well, it has to be x to the power of something. So when you multiply 2 indices with the same base, you add their powers. So a half plus what gives you 2? It has to be 3 over 2. Okay, so it's a bit tricky with those fractional powers. We've got a product of 2 things equal to 0, so that means x to the power of a half must equal 0. Or 8 minus x to the power of 3 over 2 must equal 0. Now, we're going to try and solve these 2 equations. X to the power of a half equals 0. Well, that's the same as saying the square root of x equals 0. Or what you could also do here to solve this is to get rid of the power of a half, you would take the reciprocal power of the other side. So we've done this before way back in September. So we've been solving index equations where the base is unknown. So we would take the reciprocal power of the other side to get rid of this power of a half. So we would write x equals, I would put brackets around the other side, and the reciprocal power of a half is 2, because the reciprocal means you flip numerator and denominator, so you would be squaring the other side, which makes sense because that's the same as the square root of x. How do you get rid of a square root? You square the other side. So take the reciprocal power of the other side, so 0 to the power of 2 would just give you 0. Now that appears to be a solution. Or, to solve the other equation, I'm going to get the x term by itself, so we're going to get 8 equals x to the power of 3 over 2. And again, to get x by itself, so that its power is 1, we're going to take the reciprocal power of the other side. So again, we're going to take the power of 2/3 of the other side. And then that makes the power of x 1. So we're raising 8 to the power of 2/3. So we've got x equals 0. And then the other solution here, well, 8 to the power of 2/3 means you're taking the cube root of 8. And then you're squaring the result, or you could put the power of 2 under the root as well. But I'm going to put the power of 2 outside the root. So the cube root of 8 is going to be just 2, and then 2 squared is going to give us 4. So we're going to get 4 equals x. So at the minute we have x equals 0 or 4 equals x. So there appears to be 2 points. But if you go back to the question, it says we're only considering this curve for x values bigger than 0. So if you go back to what we have, we're going to ignore this solution here. So we're ignoring, since we only consider the curve for x values bigger than 0. Okay, so this is the x coordinate of the point, and the y coordinate of the point is just going to be 0, because the point is where the curve cuts the x-axis. So it cuts the x-axis where y is 0, and it cuts the x-axis at 4. So the point is 4, 0. So point is 4, 0. So this is the point we want to get the equation of the normal at. So in order to get the equation of the normal, you need its gradient and you need the point. Well, we've got the point. How do you get the gradient of the normal? Well, you need to get the gradient of the tangent. So that's why we now work with the tangent and differentiate. So if I go up to the top, we're now turning our attention to the tangent. And we're going to get the general gradient. And that is dy by dx. So in order to get dy by dx, we differentiate the curve that we prepared at the beginning. So dy by dx equals, so take the first term, multiply the term by its power. So it's a half multiplied by 4, which is just going to give us 2. Then copy down x, and then subtract 1 from the power. And then the next term, minus x squared over 2, multiplied by its power. So it's going to be 2 multiplied by minus x squared over 2. So the 2 on the top is going to cancel with the 2 on the bottom. So that's just going to give us minus x. And then subtract 1 from the power. So it's just going to be minus x to the power of 1. Now that we've differentiated, if there's any negative powers of x, we're going to bring them back to the bottom line, and then if there's any fractional powers, we'll write them in root form. So you can see clearly here that we've got a negative power of x, so that's going to be slid, that x there is going to be slid to the bottom line again to make its power positive. So we're going to get 2 over x to the power of a half, and then we're just subtracting x. We're now going to write this in root form, so that's going to give us 2 over the square root of x minus x. The reason I'm putting this in root form is because we're actually going to be subbing in a value for x. If we were actually working out what x was, then I would keep the fractional power, but we're subbing values of x in here. So that's the general gradient. We're now going to get the actual gradient of the tangent. So actual gradient at the point where x is equal to, and remember we worked out the point as being 4, 0, so the x coordinate of that point is 4. So let's sub in 4, so we're going to get 2 over the square root of 4, and then we're subtracting 4. Now we're only taking the positive square root here, there's no negative before it, so it's just the positive. So that's just going to be 2 over 2, which is just going to give us 1. Subtract 4, and that's going to give us negative 3. So we've just worked out the actual gradient of the tangent. Now we can get the actual gradient of the normal. So we're now going to put a title normal. And then actual gradient at x equals 4. Remember, that's the x coordinate of the point. So the actual gradient then is found by flipping the numerator and denominator of the gradient of the tangent and changing its sign. So that's just going to be 1/3. So now we can get the equation of the normal because we know its gradient and we know the point that it goes through. So final bit, equation so label the point x1, y1 and chuck the point and the gradient into the general equation of a straight line. So we're going to get y minus 0, and that's equal to 1/3 upon x minus 4. We're going to multiply through by 3 to clean the denominator. Multiply out our brackets. Now, it's said in this question to give your answer, go back to it, in its general form. So general form means that move all the terms to the same side and make sure there's no fractions in your answer. So it's equivalent to me saying give your answer in the form ax plus by plus c equals 0, where a, b and c are integers. So if we go back to where we are, I'm just going to shift x and minus 4 over to the left. You could equally shift 3y over to the right, but it doesn't matter. So I'm going to have 3y minus x plus 4, and that's equal to 0. So that would be a general form for the equation of the normal to this curve where the curve crosses the x-axis. So great question, because you didn't actually know what the point was, so you had to work out what the point was, and then you had to differentiate the curve and get the general gradient of the tangent, then sub in the x coordinate of the point to get the actual gradient of the tangent, and then you can work with your normal, you can get its actual gradient, and then you can get its equation.